So, whenever we talk about creating a linear model, so we are basically trying to fit a straight line through the data so that it best represents my data, right? And because it's a linear model, so we'll be trying to fit a straight line. Had it been a non-linear model, then probably you could have tried something like this, right? And then this takes us to something called as overfitting, and all those things we'll discuss in our subsequent videos. But for the time being, my output sales based on my TV ad would look something like this, right? And in general we would write it in this way: yp is equal to mx plus b. So here we are going to use one notation, and that is I, and I is the number of records we have. So basically we have 1, 2, 3, and because we could have n number of records, right? So I will be basically from 1 to n. So my loss function would look something like this. So it will be 1 over n summation I, and we know I is equal to 1 to n, and the sum of squares difference. So basically yi will be my ith value, okay, and my sale price at that ith value I can say this one whole square. All right, and this equation can be further simplified like this. So my loss function L is equal to 1 over n summation of I, and yi is my original value. So when I say original value, say in the first record we had 22 as the original value, and I predicted something is my predicted value, which is 25 in the example that we shared in my last video. So I can replace my predicted sales with m of xi minus b. Remember, the equation is y is equal to mx plus b, and I'm just replacing this term here, which is for yp, the predicted sale price. So here we have two variables, m and b, and my main intention is to minimize this loss function. So basically I have to find a combination of value for m and b, and this is the same thing that we have seen in the gradient descent. So whenever we have to try to minimize something, we have to basically check the derivative or the gradient at, for this particular case, the derivative of the loss function with respect to m is equal to 0. So I have to solve these two equations, and the derivative of the loss function with respect to the intercept of the line should be equal to 0. So these are the two equations that we have to solve. So let's look into that. Alright, so the first derivative is dl over dm is equal to 0, and this implies the derivative will be 1 over n summation of I to capital N. Then we have 2 times yi minus m of xi minus b times minus xi, and this is equal to 0, and this implies the 2 can be cancelled and this minus symbol can be cancelled. So we have summation of xi yi, so xi is being multiplied to all the terms, so divide by n. Then we have m over n summation I xi square, and then we have b times summation I over n, I to n xi. Now this is equal to 0. So we need one more equation to solve both variables m and b. So this is the first equation. So let's see from the other variable if we can find any of these values b or m, and then we can plug it back here to solve this problem. Okay, so in this part we are calculating dl, the loss function, with respect to b is equal to 0, and this implies 1 over n, the summation from I to capital N, 2 times yi. Now this time the derivative is with respect to b, So mxi minus b, and we'll have only just minus 1 equal to 0. I would encourage you to practice along. This gives you a good understanding of this mathematical derivation, and eventually we'll see why we are even doing this, right? So this becomes, the 2 can be cancelled and this minus 1 can be cancelled, so we are left with summation of yi over n minus m over n summation of xi minus b over n times n, because summation of I and 1 is nothing, this term is nothing but n itself, so this n and this n will cancel out, is equal to 0. So this gives us a value for b. So b is nothing but 1 over n. If I take it common, so then I have summation of yi minus m times summation of xi. Now this is equation 2, so let's plug this value back to equation 1. Okay, so now I'm going to replace this value here. So what I will get is summation of xi yi over n minus m times over n summation of xi square minus 1 over n times yy. This is the b value we have collected, summation of xi multiplied by summation of xi, and this is equal to 0. So what we will get after rearranging all these terms is basically you will get m is equal to, I'm not doing those further steps, but you can just take a common of all this and you will get summation of xi yi minus 1 over n summation of xi and times summation of yi whole divided by summation of xi square minus 1 over n the summation of xi whole square. So these are the two values we will get for m and b. So let's clearly write these two equations and see what does it represent. So basically your m is equal to summation of, I'm writing it all over again, summation of xy minus 1 over n summation of xi times summation of yi, and this will also eventually turn out why exactly did we do all this messy calculations. Square minus 1 over n xi whole square, this is for m. Now if you notice, this first numerator is nothing but the covariance between these two variables x and y, okay, and the bottom part, the denominator, is nothing but the variance of x itself. So that means instead of going through this entire process of mathematical calculation, we can simply calculate the covariance and we can calculate the variance of x, and we'll get the value of the slope of the straight line. Similarly, if you notice, b is nothing but 1 over n summation of the output values minus m over n summation of xi. This is nothing but the mean of the original output value minus m times the mean of the TV ads in this example. Very simple and straightforward, and that is the main reason why we do all this mathematical calculation, so that eventually we can reduce it into simple things. And these functions are already available in NumPy library, right? Now it makes sense, right? These libraries can do these calculations really fast for you. So NumPy has a .cov function for the covariance matrix, we have function for the standard deviation and the variance, and life becomes so simple now. So we don't have to worry about so much of the math, rather we can simply use the libraries. Now it makes sense to understand that why we need the math, and do we have those functions already built up in some of the libraries and which we can use. So it doesn't matter whether you are using Python programming or R programming or any programming language for that sense. As long as they're able to do this kind of calculation, you should be good enough. So I hope you have learned something new today, and this gives you a clear picture why we need the math and when do we need the programming part, right? So I believe you have learned something new today, so please subscribe to our channel and give us a thumbs up.